Hello everybody, Gregory Carlson here for Chapter 2 of College Algebra. And Chapter 2 introduces a bunch of important topics, but most of all it introduces functions, which is an incredibly important topic, especially in calculus, because calculus is, in a way, the study of functions and the study of how they change and things you can do with them. But let's start with 2.1, which introduces two important formulas, the midpoint and the distance formula. Before we get to those, it's important to understand what an XY table is. An XY table is a way of representing points on a graph. And it's the X column is for the X value, the Y column is for the Y value. So when you see this, you should recognize that this is the point -2, 4. And so it's important to realize this is not an interval. This is not like the intervals we did in previous sections. This is the coordinate -2, 4 on the coordinate xy plane. We can see we also have the point 0.5. We have the point 311. We have the point 6, -14. And we have the point 923. So these are all 5 coordinates that are represented in this table. So if we wanted to, and hopefully this is review, we could graph these on a little graph. So -2, 4. You always do the x value first. So here's -2, 1, 2, 3, 4. That point right there is -2, 4. I'll call it point A. 0, 5. We don't move for the x value, and then we go up 5 spaces. So here is point B. Point C is 311, which would be over 3, up 11, somewhere up here. The point 6, -14, we would go in the positive x direction and down, 1, 2, 3, 4, 5, 6, and then down 14 spaces. It'd be about right there. That would be point D. And finally, point E, 923, would be over 9, and then way up high above here somewhere. Here's point E. Way up high at 9, 23. So here's quadrant 1, the positive quadrants. This is quadrant 2, quadrant 3, and quadrant 4 of our graph. So that's what an XY table is and how to plot points on a graph. If you need help with that, we will do it in class. Now, these next two formulas you need to memorize, so I'm going to put stars next to them. If I give you 2 points, you're going to need to know how to find the point that's right in the middle of those two. So if I were to draw a line between these 2 points, I'd want to be able to find the point right in the middle of them. And the midpoint formula is pretty simple. The midpoint of 2 points, I'll call it xm, ym, is equal to the x parts added together divided by 2, and the y parts added together, divided by 2. And we'll look at an example, but basically if you have 2 points, you add the 2 x components, you're basically averaging them. You add the 2 exponents and divide by 2, then you add the 2 y values and you divide by 2. And that's it. It's really simple formula. Just watch out for negatives as usual. Notice that the answer to the midpoint formula is going to give us a point. So if I asked you to use the midpoint formula, your answer is going to be a point. So you need to have these parentheses and the comma. The distance formula is a little different. The distance formula tells us the distance between 2 points. So if I draw a line between A and D, the distance formula tells you how far you have to walk to get from A to D. And if the points are above each other or horizontal to each other, all you have to do is count the spaces. But if they're not, then we'll use this formula. The distance is equal to the square root of the x value minus the x value squared plus the y value minus the y value squared. Now, in a separate video, I'll show you where we get this formula, but just because it's a little hard to read, it's x2 minus x1 squared, y2 minus y1 quantity squared. This formula is basically the Pythagorean theorem in disguise, and in a separate video I'll show you how that works. So let's use the 2 formulas in an example. Let's find the midpoint and the distance of the following: 2, 5, 16, 19. Well, let's do the midpoint first. It's nice and easy. This is x1, y1, because that's my first point. This is x2, y2, because that's my second point. So the midpoint is just add the two exponents, add the two x parts together. 2 plus 16 divided by 2. And add the two y parts together. 5 plus 19 divided by 2. And that's it. Let's just simplify a little bit. We'll add first. 2 plus 16 is 18. 5 plus 19 is 24. And now you can simplify. 18 divided by 2 is 9. 24 divided by 2 is 12. So the points directly in between 2, 5 and 16, 19 is the point 9, 12. Pretty straightforward. Let's find the distance between the 2 points. The distance formula is x2 minus x1 quantity squared, y2 minus y1 quantity squared. So let's do 16 minus 2 squared plus 19 minus 5 squared. So I did the first x part, 16 minus 2 squared, 19 minus 5 squared. Now one thing that's neat about the distance formula is you can reverse the order of the subtraction and it doesn't affect the outcome. So I could have done 2 minus 16 squared, but then I'd have to do 5 minus 19 in order to keep it consistent. But luckily the order doesn't matter. So let's simplify this a little bit. First we'll do the inside of the parentheses. 16 minus 2 is 14. 19 minus 5 is 14. Now, from here you could square that, and you could square that, and 14 squared is 196, so you could do 196 plus 196 and get an answer and then try to reduce it. But I'm going to do something a little bit more clever. Notice I have 14 squared plus 14 squared. Well, if I add those together, what's 14 squared plus 14 squared? Well, it's 2 14 squareds. So I'm not doing any trickery right there. 14 squared, think about what x squared plus x squared would be. X squared plus x squared is 2x squared. So 14 squared plus 14 squared would be 214 squared. And the reason I did that is because, look, I have a square number, which I can take out of the square root. So the final answer is 14 root 2. And so that would be the distance. And if you wanted to find out what that would be as a decimal, let's just do our calculator. 2, the square root of that, times 14. And you get approximately 19.79. So that's the distance between the points 2, 5 and 16, 19 is about 19.79 units, which is also equal to 14 root 2. So again, I didn't do anything tricky there. The alternative way to get there would be to do 14 squared plus 14 squared. And 14 squared is 196. So we could do 196 plus 196. And you would get the square root of 392. And that's when you're supposed to notice that you can do 392 divided by 2, which is 196 times 2. And then this 196 is 14 squared, so you pull the 14 out. So that, I think, is a harder way to get here. It's more clever if you can do this little simplification right there. So that's part 1, and part 2 we will do a few more examples and then an application problem. So I will see you then.